In Spain, on the outskirts of Madrid, a ground station antenna sweeps the skies for a satellite. It won't find what it's searching for just yet, however, because this is a simulation. Inside the National Institute of Aerospace Technologies is the Mission Operations Centre for Cheops, a space telescope that will soon launch from Europe's spaceport in French Guiana. But first, the International Mission Operations team must rehearse the in-flight activities, such as operating and monitoring the spacecraft, as well as uplinking and downlinking information. This is so that the telescope's data can flow smoothly to the Science Operations Centre in Geneva, Switzerland.
We build a software simulator that actually performs the same way as the real satellite. And once, of course, the satellite is built and is ready to be shipped for launch, then we train ourselves to be able to conduct the in-orbit operations. So this involves the real launch and early orbit phase and the full in-orbit validation that will last for 2 months.
On this training day, the team prepares for 3 passes, a time when the satellite is overhead and ready to send or receive information and commands. These commands can be simple, such as the spacecraft letting people know it's alive, or something more complex, like an automatic operation involving the transfer of large amounts of data. And it's not always supposed to go smoothly.
We actually don't train ourselves only for the standard or expected situations, but also for unexpected situations and real problems that may happen. So that's the reason why we have two shifts, and we try to create problems for the other shift so that they don't know what's going to happen in the simulations, and then we fake that something wrong is happening and they have to find out and, of course, sort it out.
The focus is on spacecraft control, processing data, and working together as a team, realistically simulating the critical period just after launch, when the satellite begins its orbits, the instrument is switched on, and its performance verified.
During this time, it is important to have more visibility of what is happening in the satellite. So ESA will provide more ground stations. So instead of just 4 or 6 passes, 6 times you see the spacecraft during the day, you will have one contact with the satellite each 100 minutes. So it's more easy to see that everything is okay and to solve any problem. That's why during this phase we will send commands not only from the routine ground station but also from ground station from the Antarctica from close to the North Pole.
Once in orbit, 700 kilometres above the Earth, Cheops will examine the light from a carefully chosen list of individual bright stars beyond our solar system. These stars are known to host exoplanets. Cheops will measure the size of these planets with accuracy and precision, focusing on the smaller planets. This information will be combined with measurements from other facilities of the planet's mass to learn more about what the planets are made of, how they form and evolve. The final simulation will be performed a couple of weeks before launch. Until then, the team will repeat their manoeuvres, training until the full team is not only prepared for a perfect mission, but for any surprises too.